All right, and welcome back. This is the distance formula with Mr. Hain. All right, so our essential question is how can I find the distance between 2 points on the coordinate plane? All right, big deal. We got to find the distance between 2 points on the coordinate plane, which means we have to define some points. All right, so here we go. We got our first point, 1, 3. And our second point, negative 2, 4. And if I graph them on my coordinate plane, this is where they are. Now, distance really just means how long this line is. And so we need to find the length of this slanted line. And that is the problem. The line is slanted. So if it's slanted, that means I can't use the boxes on my coordinate plane or the grid to actually measure it. I know it's longer than 3, but I don't know exactly how much longer than 3 it is. So in order to start tackling this problem, I'm going to create another shape. And while that sounds like it might be more complicated, the shapes, the green line and the red line, you see create a right triangle. And now our original question of the distance formula becomes, how long is the hypotenuse of a right triangle? And we know the formula for that. First, I'm going to relabel some of my points. And that formula is our good friend, the Pythagorean theorem. So the Pythagorean theorem gives us c squared, which is the square of the length of that slanted side, the hypotenuse. So in symbols, I'm going to rework what I'm doing in my problem on the left in symbols on the right. So here we have the Pythagorean theorem rewritten. So I have isolated on the left-hand side the length of my hypotenuse, the square of the length of my hypotenuse. So what is the length of A? And for A, I'm going to use the x values to find the length of this piece on the bottom. And really all we're doing to find the length is finding the difference between the 2 points. So if I ask what the difference between 1 and 10 is, immediately people are going to say 9, because you said 10 minus 1. So in the same way, we're going to take our x coordinates here and we're going to put them in. And we're going to find the length, 1 minus negative 2. To find the difference means subtraction. So I'm going to definitely be subtracting 1 minus negative 2. All right, cool. So 1 minus negative 2. And then to find how tall it is, I will just say 3 minus 4. I know some of you guys out there are thinking, why didn't I do x2 over on this side? Why didn't I do so? It makes it easier for me to read. So when I do the formula, I just do what starts with on the left and what I finish with on the right. Sweet. Okay, so let's take a look at what that means in symbols. Again, that's what I'm kind of just doing. So the distance squared then is the difference of the squares between the coordinates of the x's and the y's. All right, so let's go back to our problem here on the left. 1 minus negative 2 is 3 squared, and 3 minus 4 is negative 1 squared. Sweet. Well, I know what 3 times 3 is. I know what 3 squared is. That's 9. And I know what negative 1 times negative 1 is. That is 1. And again, that adds up to the square of my hypotenuse. All right, so I square root 10. And in symbols over here, really, what we've done is square root each side, like you saw that I did here in the orange square root symbols for the 10 and the c squared. And over on the right, you see that there is definitely a square root symbol on this side, but that's just because, you square root a square, and that just becomes distance. All right. I know there are some people that are saying positive or negative, but remember, distance is only positive. All right, so let's go back to our original problem over here. Square root of 10 is 3.16. I like to round to the nearest tenth. So that is 3.2 is equal to the distance of that line. And like we said at the beginning, it's got to be a little bit longer than 3. We just don't know exactly how much longer than 3 it is. So really, that's the distance between those 2 points, 1, 3 and negative 2, 4. It's 3.2. And at the heart of it, the distance formula is really just saying the length of the hypotenuse is equal to the square root of the sum of the lengths of the sides of the triangle. And if you want a deeper look at the Pythagorean theorem, please refer back to my previous video. All right. So let's keep on moving. There's a ton of practice problems that we can do. Now for the first set of 3, example A, B, and C, I'm actually going to be going step by step through these examples. Now for the other ones, I'm going to ask you to pause the video and practice your way through and just check the answer. But let's first take a look at A. So we got a label. Let's remember our distance formula. Sweet. All right. So x2 minus x1, that's negative 2 minus negative 7 squared. Y2 minus y1, that's 3 minus negative 7 squared. Simplifying through, it turns into the square root of 5 squared plus 10 squared, or the square root of 125, which of course is 11.2. All right, again, 2 minus negative 7. I use a calculator, or you can just use, when you subtract a negative, it becomes addition. So it's not, it's the same basic principle. For B, it's the same thing. I just need to make sure that I'm, this is my x2, and negative 5 is my x2, and negative 7 is my x1. As I plug it into the distance formula right here, and start simplifying, I have the square root of 12 squared plus 16 squared, which of course gives us the square root of 400. And some of you might be shouting at the screen already, I know the square root of 400, 20 times 20 is 400, and you're right. For C, it's the same thing. I just must make sure that I'm being very careful that I put in my variables in the same order. So if it's left and then right, negative 10 minus negative 8, which I have down here, it's left and then right again, negative 7 minus 1 for my y's. All right, cool. That, of course, leads us to the distance formula, and the square root of negative 2 squared plus negative 8 squared, or 68. We whip out those calculators, and kaboom! It is 8.2. Sweet. All right, so there's a lot of work in these problems. Please feel free to pause the video and make sure that you understand or rewatch this portion, because the rest of the video, I'm going to actually just kind of show the slides and the answers. But the key again is substituting correctly. If you're going to use the first point as x2 and y2, and the second point as x1 and y1, be sure you're consistent through the whole formula. The distance formula is kind of like one of those things where really it is just you're plugging it into the calculator and you're chugging away. If you do it by hand, you can kind of estimate. I know that some people like to do that. But again, the distance formula is won or lost in putting it into the formula correctly. All right. Moving on. This is where I say pause the video. I'll be here when you unpause the video to check your answers. All right, using that distance formula. For D, it's 13.3, E is 9.2, and F is 4. Again, if you want to know how I did that, I did the exact same thing that I did with the first slide examples, A, B, and C. All right, sweet. D, E, and F. Let's keep on moving and grooving. The distance formula for G, H, and I. Again, I'm going to encourage you, if you're doing this at home or reusing this as a study guide, to pause the video and see if you can do these on your own. I'll be here when you get back. I'll start talking again in 3, 2. Yep, G was 5, H was 6.3, and I was 3.6. And again, I round my answers to the nearest tenth. There you go. Sweet. Final set of problems that we're practicing with the distance formula. So J, K, and L, again, I'm going to encourage you to pause the video, especially if you're using this as a study guide or something to review the distance formula for yourself, just so that we can get the nuts and bolts of it down. I will start talking after you pause the video in 3, 2, and we're back. So J, of course, is 12.1. K is 5.1, and L is 16.4. Now, if you didn't get these answers, again, I encourage you to go back to example A, B, and C. They show exactly how I am substituting into the distance formula. Even if you substituted at the first point as x1, y1, and the second point as x2, y2, you will get the same answers. So that's it, all the examples I have for this one. If you're in my class and you have my notes, write your summary. If not, thank you for watching. And let's just keep on doing the math, people.